Okay, here's the deal. Van and I are going to conduct a little experiment about drag using go-karts.
Van and I are riding in the same kind of go-kart with the same amount of fuel. These are constant. However, Van is taller and heavier than I am. These two variables, height and weight, might affect the race, and hopefully I'll cross the finish line first. I am the superior driver.
I can't change my weight, but if I change the variable of being taller and crouch down and become more streamlined, I might have a chance.
You win.
Let me explain, Jennifer. I changed my shape, which allowed the air to flow more smoothly around me. Your shape interrupted the airflow and caused drag. This slowed you down and allowed me to win.
So what is drag?
Drag is the force that opposes or resists motion. The interruption or resistance to airflow causes drag. You've probably experienced drag when you've ever stuck your hand out the window of a moving car. When you extend your arm like this, with your palm forward, the force of drag pushes your hand back. But when you tilt your hand like this, it creates lift and lifts your hand upward. Lift and drag are a few of the aerodynamic forces that act on an airplane when it flies.
How do airplanes fly?
Well, to understand flight, you must first understand air. We are surrounded by air all the time, but we can't feel it because the air pressure is equal on all sides of our body. But what if we change the air pressure on one side of an object? Check out this cool experiment. Hey, why did the paper lift up when I blew across the top? Well, when the paper is resting against my chin like this, the air pressure on top is equal to the air pressure on the bottom. But when I blow, I change the air pressure on the top. The shape of the paper in its original position is kind of like an airplane's wing. It is curved on the top. Because of this shape, air molecules move faster across the wing's top than across its bottom. Swiss mathematician Daniel Bernoulli discovered that faster-moving fluids, such as air, exert less pressure than slower-moving fluids. Because of its shape, the air over the top of the wing moves more quickly and exerts less pressure. When the pressure on top of the wing is less than the pressure under the wing, lift is produced, and the airplane flies.
What does all this have to do with algebra and geometry?
Everything! Geometry is the study of shape and size. Geometry was probably first developed to help measure the Earth and its objects. Knowledge of geometry helps you better understand things like engineering and science.
Algebra is a mathematical tool for solving problems. Learning algebra is a bit like learning to read and write. Knowledge of algebra can give you more power to solve problems and accomplish what you want in life. At NASA, engineers use algebra and geometry when they measure and design models to be tested in wind tunnels.
Like today's NASA engineers, Orville and Wilbur Wright used algebra and geometry. By blowing a certain amount of air over models in a wind tunnel, the Wright brothers tested and compared different wing shapes, rudder shapes, and propeller shapes.
Hey, let's conduct an experiment very similar to the Wright brothers and test different shapes for drag.
Good idea, Van, but first, teachers, make sure you check out the NASA Connect website and download the lesson guide for today's program. In it, you'll find step-by-step instructions and analysis questions for today's classroom activity. Van?